Scientific notation takes small numbers or big numbers and makes them more readable. So if I have a number like 230,000, I want to change it to scientific notation by taking the taking the decimal point, which right now is at that end of the number, and we're going to move it until we are at a place where there's one digit to the left of the decimal, or you can think of it as a number between 1.0 and 9.9, less than 10. So to move it, I would have to go 1, 2, 3, 4, 5 places to the left. So it becomes 2.3, and I don't have to put all the zeros. Since I moved it 5 places, then we need to multiply it by 10 to the 5th, because that would move it back to make it 230,000. If I start with the number in scientific notation, there's a number, it's between 1 and 10, and I'm going to say it's times 10 to the 4th. So now if I want to write this in standard notation, that means I need to move the decimal point 4 places to the right. So the 2 and the 5 take up 2 of the places. Another couple of zeros would be 4 places to the right. So this actually ends up being 32,500. If I have a negative exponent, so let's say I have 2.5 times 10 to the negative 3. That negative exponent just tells me it's going to be a very small number. So I want to move the decimal point to make it a small decimal. So the 2 will take up 1 place, and then I'll have to put 2 zeros to take up the other 2 places. So I'll move it 3 places to the left, and there's my number, 0.0025. If we're multiplying numbers in scientific notation, then maybe 3 times 10 to the 7th, and I'm going to multiply it by 2.1 times 10 to the 8th. I multiply the large numbers in front. So 3 times 2.1, which is 6.3. And we should know from exponent rules that when I'm multiplying at the same base with an exponent times another same base with a different exponent, I just add the exponents. The base stays the same. So those 10s turn into times 10 to the 15th. And there's our answer, which is a very large number. If I was dividing numbers in scientific notation, so let's say 9 times 10 to the 8th divided by 3 times 10 to the 12th. I divide the base numbers. So 9 divided by 3 equals 3. And then the shortcut rule for exponents, if the bases are the same, is to subtract the exponent. So I take the top exponent minus the bottom exponent. 8 minus 12 is actually negative 4. And again, that ends up being a very small number. If I wanted to write this in standard notation, right now the decimal point is 3.0 times 10 to the 4, so I would move it 4 places to the left. So the 3 would take up 1 place. I would have to add 3 zeros. So that's actually that number in standard notation. Let's say I multiplied 2 numbers in scientific notation. So 7 times 6 is 42. 10 to the negative 8th times 10 to the 12th. I'm going to add exponents. Negative 8 plus 12 is positive 4. Let's see my answer now. When I look at that, that's not scientific notation. 42 is too big. Remember, I have to have a number between 1 and 10. One number to the left of the decimal point. So right now, that decimal point on 42 is right after the 42. So I need to move it 1 place back. I need to turn this into 4.2. I've just made that number smaller. I went from 42 down to 4.2. Do the opposite with the exponent. So since I moved it one place to make it smaller, I'm going to make that exponent one place bigger. And there's our answer in scientific notation.